Hi, welcome to another video. My name is Bharat Divyam. In this video, I'll be talking about arithmetic versatility. So, yesterday in social media, I saw this posting, and it got me wondering, how long did the Mughals rule? How long was the Mughal rule? So, this image shows me that 1526 was a starting point, but when did it end? So, in order to find how long the Mughals ruled, I need to know when it started, which the image tells me is 1526. This is not something that's commonly remembered. People probably would forget when asked out of context, but when it ended is something that's kind of in our popular imagination. And the answer is 1857 because that's the first war of independence for India. So now the question is, what is the duration between the start and the end? That's how long the Mughals ruled. So in order to do that, math would teach you that you just need to subtract 1526 from 1857. It's a straightforward subtraction. In fact, you can follow the procedure of starting from the units digit. 7 minus 6 is 1, 5 minus 2 is 3, 8 minus 5 is 3, and 1 minus 1 is 0. So being very procedural can absolutely get you the answer. But then let me ask you another question. How long did Akbar rule? So the image will tell you that he started his rule at 1556. You need to subtract that from 1605 is when he ended. I mean, application of math, right? To find the subtraction and the difference to get you the answer. But here's the issue. When I gave this problem to many of my students, at least a couple of them who came back with 149, right? Why does this happen? What is the reason for this error? The reason for the error is because of the procedure. The error occurs because of the procedure. In this one, you need to do a carryover. And when you do a carryover, the 6 becomes a 5, or 16 becomes 15, and therefore the last one is 0. But many kids, let the 0 borrow 1, but they do not deduct 1 from 16, and therefore it stays as 16, and when they subtract, it's 149. And what's even worse is that you don't pay enough attention to the fact that 149 is just too large for one kingdom or one ruler to rule, right? One king to rule. So the error checking mechanism or error recognizing mechanism is somehow lost. Is there a better way to do this? And that's where a new method can come in. Think of the entire timeline. He started in 1556, he ends in 1605. So it's this difference, this distance between 2 points on a number line that we need to figure out. And think of it as a journey from 1556 to 1605. We just need a certain number of pit stops. The first pit stop is 1560. It's a round number. Just after 1556, we know that's 4 years since he started. We also need another pit stop just before his end, which is 1600. It's just 5 years before the end of his reign. And the difference between 1560 and 1600 is much easier to solve, which is only 40. And therefore, you can be 100% sure that the answer is 49. So when somebody asks you, can you divide 81 by 3? Thinking of 81 as 9 times 9 and then cancelling 1 9 with the 3, giving you 9 times 3 is 27. That's one way to do that. Another way to look at it is to say that it's 60 plus 21. 60 is nothing but 20 times 3. And 21 is nothing but 7 times 3, and therefore it's 27. The same question asked in a different way, or a different question asked about 81, which is what's the remainder when 81 is divided by 7? So versatility here is to know that 77 is 11 times 7, and that's 4 less than 81. So you know that 77 is the nearest multiple of 7, and therefore 4 has to be the remainder. What's the nearest perfect square to 81? We know that 81 is 9 times 9, and therefore it's 9 square, so which means either 10 square or 8 square is going to be the answer. 8 square is 64, the difference is 17, 10 square is 100, the difference is 19. So the nearest perfect square is 64. But being able to look at 81 as 9 square is important. Divide 81 into groups of 6. How many empty seats would be there? Maybe that's a question. So you think of it as 60 plus 21 or 60 plus 24 minus 3. So these are the different ways in which you can just approach a single number. It's like looking at it from different perspectives. So what is AV? Looking at numbers from different perspective is arithmetic versatility. Procedures and traditional method is just a backup. Building mental model for mathematical calculation is very much part of the versatility with respect to arithmetic calculation. So for example, to find the timeline of Akbar's rule, we used a number line. That's a mental model. Breaking down the problem into three parts, right? So we said, hey, from 1556 to 1560 is part 1, 1560 to 1600 is part 2, and 1600 to 1605 is part 3, and therefore breaking it down and combining it back helped us get the answer much